jam it in. I think it'll give us some time on Monday to review anything that you want to review. All right? You have all 6 questions in front of you now. So you should, I think, hopefully be somewhat confident that you're ready to prepare for next week. The endocrine system overview, I don't have a kind of, this is what you're going to get out of it list for this one. Okay? Overview, with the nervous system, integrating and coordinating the activity of the body's cells. So far, we have found out that the nervous system can have a pretty big impact on a variety of tissues. Turn them on, turn them off, okay? It's not the only system that does this. It is allied with the endocrine system. As an example, if you are working on your mass activation question for the test, one of the cool things about the sympathetic division of the nervous system is it gets the support of the endocrine system because the sympathetic turns on which gland? Which gland gets turned on by the sympathetic when it activates? The adrenal medulla, okay? Which releases norepinephrine, which helps support mass activation and support sympathetic. So you saw right there an example of the 2 systems working together, and it's really true. They do work together. Influence metabolic activities via hormones transported in the blood. Nervous system can do this, but the endocrine system is actually a little bit more keen at kind of setting a pace in the body. One thing you may have heard is people who are hypothyroidic, okay? Thyroid produces a couple of hormones, one really key hormone that kind of sets a biochemical pace in cells. It sort of sets the speed of the metabolism. The more of that hormone, the faster the metabolism, the slower the metabolism. For some reason, it seems to be quite common for hypothyroidism to be occurring in the United States, and there are a lot of people who are on synthetic thyroid hormone to try to boost their levels. What's some of the, let's say, symptoms of being hypothyroidic? Being cold, gaining weight, being a little slow, okay, not mentally slow, but sluggish, that kind of thing, because the stimulus for your basal metabolic rate is reduced, okay? Response slower but longer lasting than the nervous system. This is one of the key differences between endocrine and nervous. Nervous can activate and bring about change very quickly, but as soon as the action potentials are over, the stimulus is gone. Hormones can hang around for a while, and they can sustain a change. Examples of control and integration. Hormones play a role in just about everything that goes on in the body, but they are really key in controlling reproduction. I'm not talking ejaculation. I'm talking getting the body ready to reproduce. Okay? Ejaculation is not a hormonal thing. It is a nervous thing. But getting all the sex cells ready to go and getting the uterus ready and all that stuff, that's all hormonal. Growth and development. Yeah, there's a nervous role here, but for the most part, growth and development is controlled by hormones. Okay? Maintenance of electrolyte, water, and nutrient balance of the blood. It's really true that the amount of these sorts of things in your body is directly related to hormone control. Regulation of cellular metabolism, energy balance, you heard about that already with the thyroid, and then mobilization of body defenses, okay? Communication in the immune system via hormones, okay? So it's a good start. Some of you maybe heard me talking about mixed and single function endocrine glands. We're going to take a look at a map of the body and take a look at some of the glands that produce hormones. And in reality, just about every body tissue produces some sort of chemical messenger. If you read this chapter carefully, you will find that there are some substances that are released by cells that influence the cells themselves. It is a form of chemical messenger. There are some substances produced by cells that affect cells that are nearby. And then there are some substances produced by cells that have an effect elsewhere some distance away from the site. Okay? So we are going to find out that just about every tissue in the body produces hormones, but there are some that are exclusively hormone producers, and then some that do a little bit of everything. Our exclusively hormone or endocrine glands are these here: the pituitary, thyroid, parathyroid, adrenal, and pineal glands. Okay? The only thing they do is produce hormones. But there is the hypothalamus. And we've heard that the hypothalamus has a role in the control over the autonomic system through action potentials, but then it also controls the pituitary and produces its own hormones. It truly is kind of has multiple roles. And then hormone or tissue like these are called mixed glands or mixed function glands. Pancreas is a great example. If you don't know about it already, you will find out next semester. The pancreas is absolutely key to digestion because of the fluids that it produces, not because of the hormones it produces. On the other hand, the pancreas is very key, not completely key, but very key to the regulation of blood sugar. So it has both an endocrine and a exocrine function. I was telling someone about gonads. Gonads is a generic term. This was Monday, not just general talk about gonads. Last Monday in the lab. They produce sex cells, eggs and sperm. They produce hormones. In ladies, estrogen primarily, okay, some progesterone. In guys, testosterone and another hormone called inhibin. Okay? So they do both. Mixed function. Other tissues and organs that produce hormones: adipose, thymus, cells in wall of small intestine, stomach, kidneys, heart, and this list could go on and on. The heart literally does produce hormones. The heart's atria are their smaller chambers, the chambers that don't generate a lot of force, okay? And as they expand, as blood pressure increases in the body, as they expand, they release a hormone that causes the kidney to lower the amount of water in the blood and thereby decrease blood pressure. It's a neat system. Blood pressure controlled by the heart itself by releasing a hormone. Okay? Okay. This is the basic map. These up here I don't need to tell you about. This is the thyroid. The thyroid is usually just inferior to the larynx, the voice box. Shown embedded in the thyroid are nodules of tissue, groupings of similar cells called the parathyroid glands. These are typically shown, or it's visible only through histological examination. This is the thymus, which is shown oversized in this individual because this individual is an adult. In adults, the thymus is greatly reduced, almost non-functional, really. In children, the thymus is quite a bit bigger. There are the kidneys, and there on top of the kidneys are the adrenal glands. You should be pretty comfortable with those. And then right along the stomach is like right in here, there is the pancreas. Okay? These are single function and true endocrine glands, the adrenals, but this is a mixed function gland. Down here, you're seeing a portion of the female reproductive system and the gonad known as the ovary, and down there, the male reproductive system and the gonad known as the testes, or testicle, or whatever you want to call it. Okay? This is not inclusive. Okay? There are a lot of other tissues that produce hormones. Now, getting to that one question that you got this morning, you can kind of sum up the hormones of the body, the major hormones of the body, as existing in two chemical classes. There are other classes. These are the two main ones. Those that are based on the peptide bond, the bonding of amino acids to form short chains known as polypeptides or proteins. Okay? Some of our hormones are actually just slight modifications of individual amino acids. Okay? So they call them amino acid-based hormones. And not all of the amino acids are water soluble, but many of them are. So typically, our amino acid based, our polypeptide based hormones, our protein based hormones are typically a little bit more soluble in water than other kinds of hormones. Travel through the blood without needing a stabilizing or binding protein. Okay? Often short-lived, existing for seconds or minutes. When a polypeptide or a modified amino acid or a protein is floating around in the blood, there are enzymes in the blood that are ready to degrade it. Okay? So you play this game between releasing the hormone and hoping it gets to its target before it's degraded. But then also being able to control the release, the effect of each release of hormone. If the stuff hangs around for a long time, then you begin to lose some control over the effect of that hormone release. If you release hormone and then destroy it, you can release it again, and you can really begin to monkey around or play around with physiology. But if you release the hormone and it hangs around for a while, then you lose a little bit more control. The steroid is the type that tends to hang around a little bit longer. So these, because of their chemistry, because of the fact that there are enzymes in the blood looking to break down proteins and chunks of proteins, they don't last long. They're not stabilized. The steroid is a little different. This should be expanded to steroid and lipid-soluble hormones. Not all of our, let's say, lipid-soluble hormones are steroids. Steroid is a type of hormone which is based on the structure of cholesterol. Cholesterol may be the source or the raw material to make the hormone. So any of our hormones that get the name sterone at the end, suffix sterone, are going to be steroids. Testosterone, progesterone, okay? They are synthesized from a molecule of cholesterol. It gets a bad rap, but it's a pretty important molecule for us. Okay? They come from various sources. Testosterone, progesterone, estrogen, gonadal. There are other ones called cortisol, okay? There's a few others that are adrenocortical. What does this mean? It comes from the adrenal gland, but the adrenal gland has an inner layer called the adrenal medulla. That is a norepinephrine producer. And it has an outer layer called the adrenal cortex. And that one produces a number of hormones. So adrenocortical means the cortex of the adrenal gland. It's not uncommon for organs to be described as having a cortex and a medulla. Okay? So you have to make that jump because you've learned it in another scenario, okay, or another scene. Most of these are lipophilic and poorly water soluble. Therefore, when they are released by their releasing tissues, they're not going to be very soluble in the blood. I maybe haven't said it yet, hormones use the blood to move around. So if it's not very soluble in the blood, it isn't going to go very far. So there are proteins made by the liver that are called transport proteins or binding proteins. And when the steroid-based or the lipid-soluble hormone is released, it binds reversibly to a transporting protein. What this does is stabilize the hormone pretty significantly, prevents it from being either urinated out or destroyed. Let's talk about this urinated out thing. You will learn next semester that the way the body makes urine is through filtration and then a lot of active transport. So it comes down to size. Whether substance gets from blood to urine depends on size and solubility. If it's super water soluble and super small, it's definitely getting into the urine. The question is, does it get pulled back into the blood? And in the case of our non-steroidal hormones, they if they're small enough, they get